So then, continuing from the first video, there are other types of compound statements. The most common one after conjunctions and disjunctions, ands and ors, is what's called a conditional statement. And this is a statement where I can write the sentence in if-then form, which is the way we're most used to seeing them, even though this is not the most common way they appear. But that we'll deal with when I get back in the classroom. If it's written in if-then form, the statement that immediately follows the word if is called the hypothesis. The statement that immediately follows the word then we call the conclusion. So if I use P to represent the hypothesis and Q the conclusion, then my notation in symbols for a conditional statement is I'd write the hypothesis followed by an arrow that points to the right, followed by the conclusion. And I would read this as if P, then Q. So an example of this would be if the forecast calls for rain, then I will take an umbrella. The forecast calls for rain would be the hypothesis. And I will take an umbrella is the conclusion. Please note the word if is not part of the hypothesis. The word then is not part of the conclusion. They just help me see what statement is the hypothesis, what statement is the conclusion. Now, in terms of telling whether or not a conditional statement is going to have to be true based on the truth values of the individual statements of the hypothesis and conclusion, this is going to feel a little bit weird. The only time that a conditional is true is in two cases. First, P and Q are both true, or P, the hypothesis, is false. So if P and Q are both true, in other words, the hypothesis is true and the conclusion is true, then my entire conditional statement will be true. But if my hypothesis is false, it doesn't matter what the truth value of the conclusion is. If the hypothesis is false, my conclusion must be true. And this feels weird because then we could get away with saying if donuts fall from rain clouds, then Mr. Carilla is the ruler of the world. And that would have to be a true conditional statement, because the whole idea of it is the only way I could show a conditional statement is false is by providing a counterexample. So a counterexample would be a case where I show that the conclusion happens when the hypothesis doesn't. So for example, if I have my original if-then statement, if the forecast calls for rain, then I will take an umbrella. If I can show an example of when I would take an umbrella somewhere and the forecast did not call for the rain, this would be a false statement. So for example, a counterexample I could give is, I'm going to go to the beach on a sunny day. I would take an umbrella even though the forecast would not call for rain, and that counterexample would make my conditional false. It's very much like how we approach inductive reasoning. But if I have a ridiculous statement with a false hypothesis, like if donuts fall from rain clouds, then Mr. Carrillo rules the world, is I'd have to give an example of me ruling the world where donuts do not fall from rain clouds. And that's impossible to provide the counterexample, so we're forced to assume it's true. So these are the only times conditionals are true, or if the hypothesis and conclusion are both true, or the hypothesis is false. One thing to watch out for is, I already mentioned at the beginning of the video, that conditional statements are not normally in real life written in if-then form. They're usually hidden in this way. So, for example, a mammal is a warm-blooded animal is an example of a conditional statement. It's just not written in if-then form. I could rewrite it in if-then form as saying, if an animal is a mammal, then it is warm-blooded. Meaning the animal is a mammal would be the hypothesis, and warm-blooded is the conclusion. And if I wanted to check that, I would just reverse this. And if I said if an animal is warm-blooded, then it's a mammal, and see if that could also make sense. So, for example, the sum of the measures of two supplementary angles is 180. I could think of that as if the measures of two angles is the sum of the measures of two angles is 180, then they're supplementary. Or I could say if two angles are supplementary, then the sum of their measures is 180. You have to kind of pick the order that makes the most sense to you. And I know that seems kind of weird to say. So again, if you're conditional to show conditional is true, the hypothesis and conclusion are both true, or the hypothesis is false. To show conditional is false, provide a single counter example.